What is going on, guys? Welcome back to the channel. In this video, we're going to be talking about things we can learn from functions. This video will cover everything we can learn from functions in our videos that we could also represent graphically or geometrically, algebraically, and verbally. All right. Before we hop into the meat of the video, follow the channel on Instagram, YT_SwissArmyTutor, where I post updates to the channel when they're needed, and also behind the scenes footage. Also, leave a like and subscribe to the channel for further content. So let's hop right into it. Okay. So we know from a previous video, a function is defined. That's what we see. Function is defined as a relation with one output for every unique input. So, if you guys remember the box, pretty much we have a 1, 2, 3. If this is our x, our function value f of x, 1 has a 3 unique, 2 has a 6, for example, and 3 has a 9. Alright. For every input value, or for every input value, everything in the domain, all of our x's have one output, as you can see here. Okay. So this is an example of definition of a function. All right. So what can we take from a function? So let's just draw in a random curve. Okay. Okay. So taking that. All right. Just drawing a random curve now. It's not meant to be perfect. Okay. So. Alright, so the first thing we could find on a function is the domain. Alright. So let this graph be f. Function f. Okay? Sorry guys. I'll try to write hook-handed for you guys. So we can find the domain. And pretty much with the domain, so that geometrically is all the values that we accept in X. So all acceptable input values. In fact, we talked about it briefly in the channel, on the channel. But every time we talk about the domain and range, so the domain, there's unique functions that we can talk about. Such as polynomials, exponential, rational function, logarithmic. Sorry guys, didn't mean to write that hook-handed or crooked. Log, trig, inverse trig. And every function has a domain, every function has a range. Alright? And so the domain of a function is every acceptable input value. Alright, so in this case, there's an input value, there's a unique output value accepted for each input value. Pretty much, so the domain's all real numbers, or negative infinity to positive infinity, and interval notation. All right. So pretty much, we put in a value. We're allowed to put in a value, and the function spits out a value. Kind of like a vending machine spinning. If it's undefined, it wouldn't be accepted. Your calculator would error out in other cases. In all the cases, actually, it's like a vending machine spitting out your dollar because it's not perfectly. It's not good enough for it to take. All right, so the next thing we could find is the range. Okay, so what is the range? All right, so if the domain is all the acceptable inputs, what about the outputs? That's what we call the range. All right, so the range is all acceptable outputs for every input. Okay, and so that goes from the lowest point to highest point. To highest. Sorry, guys. Okay. So let's keep this in. All right. So the range is all the output values. So if we have a point, all right. So if this is x, and this is and this is y, all right. So pretty much, the coordinate x, y also could be written as x f of x. Pretty much, this is the domain. The x is the domain. F of x is the range. If that makes and so that's pretty simple. All right, so then the next thing we'll find is where things are increasing and decreasing. All right, so increasing means a function is that as x gets larger, the function grows. So we could find. So let's draw another curve to best show it. So let's call this G. Let this graph be G. Okay. And pretty much, so let's just draw a random curve. Again. Okay. Alright, so we could find a function increasing and decreasing. Okay. So a function's increasing as x gets larger. F of x gets larger. Alright, so geometrically on the graph, alright, as the function's getting larger, alright, so as you guys see here, so it's taken from 0 to whatever x value, the function's growing. It's getting bigger and bigger and bigger. So that means the function's increasing. In this case, on the interval from 0 to infinity, including 0. Actually, no, not including 0. Sorry. And this is a calculus concept. We spend quite a bit of time talking about this using applications of derivatives, in the first derivative tests, second derivative tests, and so on and so forth, and the extrema tests. Right. Then we also have decreasing. So as x gets larger, f of x gets bigger. Alright, so geometrically, alright, let's say this point, okay? So this function starts increasing, it's bigger it starts growing to a point, and then it starts going back down, and it starts getting more and more negative. The function, x is increasing, and it's just decreasing until it reaches a point. So from this point to this point, it's decreasing. So pretty much, the function's getting smaller as x is growing, is the definition of decreasing. All right. For increasing function, we could say, okay, pretty much as x1, so as one x value gets bigger, f of x. I can't really. No, we can't do that. My bad, guys. So as x gets larger, f of x is getting larger, and this is a common notation I see in my you'll see in a calculus book. Okay. All right, and decreasing it, the signs. So the x1, x2 stays the same, but the signs flip. Pretty much. As I was saying, as we're putting in more values for function, for the function, the function's getting smaller. Sorry, guys, you guys couldn't see that. The function's getting smaller. Okay, so and there's one last thing. So there's absolute extrema. All right. So what's extrema? Extrema is the maximum minimum. Okay. So the maximum. So a maximum is pretty much this, right here. That's a maximum. All right. We talk about this quite a bit in calculus 2, as well. And this is the minimum, pretty much. So a function. So a maximum goes. It goes from. So a maximum goes from increasing to decreasing. And a function goes from, and a minimum goes from decreasing to increasing. But an absolute means an absolute extrema means the highest and lowest max or min. The highest values of the function. Okay? And a local, and so for every other extrema, are maximum, and minimum values. Okay. Now, meaning pretty much this is just happens to be all functions. So pretty much all of the extrema in a function. So in this case, all right, this function starts from this point, and goes larger. It gets larger to a point, peaks, and starts decreasing to a point. Okay, and we call that so we call this a local maximum, and then it's going to go down. The function's going to go down. It's going to keep decreasing to a point, turn around, and goes back up, and we call that a maximum. And this is what we call a turning point. Okay, and the last thing, and there's one last thing we can find too. Alright, so in this case, there's no absolute maximum or minimum because the function it continuously increases and decreases. So unbounded intervals, of course, to infinity. And so the last thing we can find is a point of inflection. Last major thing we can find to curve sketch, of course, is a point of inflection. And what that means is if a function gets bigger, it stops for a second. So the easiest way to show it is right here. Okay, so the function's increasing from this interval. Oh, sorry, guys, from this interval. So the function's increasing, and then it acts like it's going to stop for a second. Act like it's going to change directions, but it doesn't change direction. It goes back to increasing. So that's what we call a point of inflection. And the same thing goes for decreasing. If the function were going down, let me sketch that real quick. And it would stop, and it started going down again. That's a point of inflection as well. Okay. And so I also forgot to mention the functional value. That's the most we can find a functional value. Which is f of x, pretty much. So if we plug in x to f, we get out a function. We get out a number n. That's just all functional value means. With that being said, guys, these are the most important things you guys could find. You guys could learn from a function. I'm sure I missed quite a few. If you guys know of some I've missed, or if you guys see more that I missed, let me know in the comments down below. Leave a like, comment, subscribe to the channel, and I'll see you guys next time. Later.